Okay, guys, for our notes for points, lines, and planes. All right, first thing we're going to talk about is undefined terms. The most basic figures in geometry are undefined terms. Okay, these words do not have formal definitions, but there's an agreement that what they mean. The following are undefined terms. The first thing we have here is a point. The point has no dimension. Okay, is an exact location in space with an indefinite size and shape. All this means is it's a dot. Okay, our dots that we see that we plot on coordinate grids, these are points. And the sketch of a point is literally a dot. Okay, and we just call this point A. And that's one way that you'll do that is you can either name it point A, or you can also call it just A. Okay, so our points we will name with one letter, uppercase letter. Okay, we can call it A or we can call it point A. Your line has one dimension. Okay, it's going to go one direction. So you got, 3 dimensions, your X, Y, and your Z. It's going to have one dimension. It's represented by a line with 2 arrowheads. And it's going to extend without an end in both directions. It will never, ever end in either direction. So here, if I take a line, let's say we've got our line, right? But we need 2 arrowheads, one on each side. The arrowhead says it's going to keep going on and on and on and on. I'm going to put a couple points on here. Remember, we've got points from up here. There's a reason why. And then what I'm going to do is up here, I'm going to put a little cursive L. Okay, it's a cursive lowercase l. So the way to name this is you can either call it line L, that cursive L, or what you can do is you can name it with any 2 points on that line. So we could call it line AB, which in order for us to understand that this is a line, you have to put exactly what the line looks like. Line with the 2 arrowheads above it, or we can call it does not matter what order they go in, we can call it line BA, either one of those. Okay, just any 2 points. If there was another point on it, just grab any 2 points that you want. Your plane has 2 dimensions. Now we're going to go X and Y. We're going to go 2 different directions. This is like a sheet of paper. Okay, so we have 2 dimensions. It's going to be a flat surface, and it's going to extend indefinitely in all directions. So we draw a sketch of a plane, in case you need to do this. We're just drawing, like, a lot of times it's like a parallelogram. Honestly, you can do a rectangle, a blank sheet of paper, a wall. All of these things represent planes. Okay, so on here, I'm going to put a couple points here. Let's put A over here. We'll put point B here. Let's put point C over here. All capital letters we learned up here. Okay, and then I'm going to put a little lowercase cursive or italicized M. All right, so here we can either call it plane M. Sorry, I messed that one up. M. Okay, notice that both the line L and the plane M, these are both lowercase italics or cursive, or we can name it with any 3 points that are on the plane. The line is 2 points, and this will be 3 points. Now, with a plane, there's no symbol above it, like with line over here. Okay, so all we're going to do is we can just call it A, B, C. Okay, you can put these 3 points in whatever order you want to. You can call it B, C, A. You can call it C, A, B, whichever order you'd like to. All right. So these are going to be our undefined terms, meaning there's no definition to it. They're going to, especially with the line and the plane, they keep going on and on and on forever. They can be anywhere. Okay. Your defined terms now. Okay. These have start and stopping points. Start and or stopping points. So so looking at our line segment. Now your line up here and your line segment, they both have the word line. Your segment, you think of like segments of a worm. A worm has several different segments, and there's a start and a stop to each one. So your line segment is going to be a piece of a line consisting of 2 endpoints, okay, and all the points in between it. So when we have a line segment, what this is going to look like is we've got that line, but at the ends, instead of having arrowheads, we have points, and those are your end points, okay? And let's call this, F and G, point F and point G. Now, there are only 2 ways you can name this line segment. Your line segments have to include the point that starts it and the point that stops it. So let's say if I had another point in here, let's just say E, I cannot use E if I'm talking about the whole entire segment. I am going to erase that though, okay? If I said FE, I'd only be talking about that space right here. So we want to make sure that we're using the two end points, where the segment starts and where it stops. The two options you have here are going to be FG. Now the line above it is going to be exactly what this looks like, but you don't have to draw the actual points. It's going to look like this. That means segment FG. Notice we didn't put the arrowheads. The arrowheads would mean line. This stops. Starts at F and ends at G, or it starts at G and ends at F. So the other way that you can do this is you can move those two letters around. So it's GF. Okay, so again, it doesn't matter what order those two letters go in. When we move to array, all right, array is going to be a piece of line consisting of one endpoint and extending indefinitely in one direction. What I like to say is this is if a line and a line segment had a baby, okay? So you're going to have the line segment part of it where you have a point, starting point. It's like a ray of the sun. It starts at the sun and it shoots outward and it's going to continue on in one direction. Okay, so there's an end point like the segment, and then you've got an arrowhead like your line up above. Now, in order to name array, we're going to have a second point on here. Let's call this H and J. So exactly like with our symbols, okay, or with our line and our segment, where the symbol that goes over it is going to look like this. It's going to be array. Now, very, very specific how you have to name this, okay? You have to start, the name starts with the endpoint where the array starts. So I have to start it with H. I don't get an option here. I have to start it with H, and I can pick up any point along the line. If I had another point right here and say E, I could name it array HE, HJ, but here I only have 2 points, but it has to start where the array starts, at this endpoint. And you just pick up any point along the way. So this would be array HJ. The ray symbol always is an arrow pointing to the right. Okay, what we're going to put here is HJ with the arrow going the other direction, put a circle around it, put a slash through it. We cannot name it with the arrow around. Okay, we also cannot name it ray JH. This is a no-no also. All right, we cannot name it that either. It has to start with where it starts and pick up any point, and you have an arrow pointing to the right. Opposite rays. Okay. Your opposite rays are simply going to be two rays that share the same endpoint, okay, and they're going to continue in opposite directions. So what this is basically if you have a line from like up here, but you have 3 different points on it. So what ends up happening here is, let's say that we've got this point L. I'm going to have ray over here, ray LM, okay, sorry, it should be capitalized, LM. And then in the complete opposite direction, okay, I'm going to go ahead and put a point over here, call this K, point K. So it's going to be a straight line, not a line segment, but a line with rays, and it's going to have a point. It's going to have 3 different points. That middle point right here, that's going to be where the opposite rays start. So here we have ray, we look at the first one, LM, it has to start with that L, and ray LK. The way you know the opposite rays is, look at this. We start with the same letter, okay? But again, it's going to be a line, but you're going to have a point in the middle, and they're going to go through points in opposite directions, extending indefinitely. Remembering that that arrowhead tells you that they're continuing indefinitely. They never end, okay? So next, let's talk about collinear, coplanar. Okay? Collinear is going to be points that are on the same line. So collinear, co meaning together, linear meaning line, together on a line. So we have points on the same line. So if we have this line, like we have that ray, even if we take that, let's say we've got P here, we have Q here, and we have R here. They are collinear. They're together on the same line. If I had another point somewhere over here, would not be collinear. But these 3 are collinear because they're on the same line. Together, collinear line. Non-collinear. So that's what we'll look at now. So let's go ahead and draw another line But this time, let's put point S right here, let's put point U here, and let's draw T off to the side like I was talking about earlier. This is non-collinear, okay? These are points that do not lie on the same line, all right? So you cannot say point S, U, and T are collinear. You can say point S and U are collinear, but if you say point S, U, and T, they are non-collinear. Coplanar. We have points that lie on the same plane. Co together, planar, plane. So if we have a plane here, we'll draw that plane like we saw on the first page. And let's say that we've got W here, X right here, Y right here. These three are coplanar. They fall on the exact same plane. They're all together on this two-dimensional plane. And just like before, you're non-collinear, okay? You have points that do not lie on the same plane. So let's take a look at what that looks like. If we have this, we have a plane over here. We'll go ahead and use the same W and X. And then let's say that Z is over here. These three are not coplanar, so they're non-coplanar. So I would say W, X, and Z are non-coplanar. So we take a look at an example here, okay? We're going to name all of the points shown. So all the points here, I've got A, I've got point B over here, all the dots. Point C over here, I've got point D, I have point E right here, I'm just going in alphabetical order. I have point F. What you need to notice is this H is an uppercase letter, or italicized letter. Sorry, your plane is supposed to be uppercase. And then your G over here is italicized. There is no point. Those are actually the names of the plane, which we'll look at in a moment. Okay? We're going to give two other names for the line AE. So we look at the line AE. So we're going to find the line that has arrowheads. See the arrowheads? And we're going to find two other names. Well, one, we can use this little italicized lowercase l. Okay, so we can call it line L. Or we can name it, pick up any 2 points that are on there and put them whatever order you want. When you have a line, you could do that. So we could say line A. See, they use AE. We can use line AD. So we could say line, put in the symbol, AD. It says two other names, but I want you guys to also see you can use line E or line DE also. So I'm going to go ahead and put that one on there too so you can see that. See several different examples. Okay? We want to give another name for plane H. So plane H is going to be this plane right here. Okay, we're looking at this guy right here. And if we remember, we can name our plane with either the italicized or cursive letter up here or any 3 points that fall on that plane. Well, I want you to see this line right here. We'll talk about intersections in the next notes. But this line is the intersection of the two planes. So these 2 points, D and E, are going to fall on this plane. Now, F, I need you to see, F is going to fall on plane G. So we cannot use that point there. Okay? F is on plane G. But we can use point, we can say, okay, plane, and the other point that's on plane H is the C. So we can use C, D, and E. Now, again, with plane, you can put them in whatever order you want to. Okay? We're going to name a line segment. There are several line segments on here. Okay? Right now, we have the line with the arrowheads. Remember, when we use line segment, the symbol is just this, and we pick up the starting point and the ending point. So from here to here, there's segment AD. Notice how I stopped it. So it starts at A, ends at D. Or segment DA. Okay, it starts at D, ends at A. You put those two letters in whatever order you want to. But we say, okay, it's a segment because of this bar right here. So we can say segment AD. I know it says name a line segment. We're going to go ahead and look at a couple more. You could call it from here to A. Okay? Even though point D is between them, it doesn't matter. From here to here. Here to here. We have segment AE or segment EA. That's going to be this whole entire thing. So we could say segment EA. There are several segments on here. We're going to look at two opposite rays. We only have one option. Remember what our opposite rays look like. So we have to use our line. We use that middle point, as the starting of the name of both opposite rays. So when we do our rays, remember our rays go to, they point to the right. We have to start with point D. We have ray DA, so that's going to be this guy right here from D, and it's going to go indefinitely in one direction. So ray, you cannot call it ray AD. That does not work. You have to start with this point where it starts, and then go through another point. And then the other side, we have ray DE. You cannot mix those letters up. It starts at point D and goes through E. These two are opposite. They go in completely opposite directions, creating that line. So then we have ray DE. Put that and sign in between. 3 points that are co-linear. Co-together, linear on the line. So here is our line. Let's pick up 3 points. It says 3 points that are on this line together. We have point A, D, and E. The other points are not on that line. C, F, and B are not on that line. Now we want to look at 3 points that are non-collinear. So we can grab any 3 points we want as long as they're not A, D, and E. We can grab 2 that are on the line and 1 that's off the line. It doesn't matter. So here we could say, okay, point D. And then if you look, point F is not on that line. So point F is non-collinear. If you look at C, C is non-collinear also. So we have D, F, and C. And you want to keep going. A, as long as we're not, all 3 points are not on the same line, they're non-collinear. We're going to look at 3 points that are coplanar. Okay, so that kind of looks like an E. Non-coplanar. Coplanar. So we're on the same plane together. We want 3 points. We have a couple different options here, depending on if we want to look at plane G or plane H. Let's look at plane G right here. Okay, so looked at H earlier. 3 points that are on this little parallelogram together. We got D and E that are going to be on that line. And then F, like I told you earlier, is floating out here. It's on plane G. It is not on plane H, which we'll get to in a minute. Okay, so then we'll say point D, E, and F. A we cannot use because, well, technically this plane does go on and on and on and on forever, so A would be considered coplanar with it. Okay. Now we're going to name 2 points that are non-coplanar. So we need to pick out 2 points that are not going to be on the same plane together. Well, the easiest thing is we see B. I don't know where B is. I don't know if it's coplanar with, or if it's on plane H or plane G, because it's floating way out here. I have no clue where in space point B is. So you can grab point B and then any other point that you see. So let's just go point E. So point B is floating out in space. You could also say, point C and point F, because they're on separate planes. Point F is on plane G, point C is on plane H. Those are non-coplanar as well. Now we want to look at our points B, E, F, and C coplanar. Are they on the same plane together? So, well, we already discussed that. We don't know where the heck B is. So B is floating out. So we look at E, F, and C. Well, C is not on the same plane as E and F. Okay, so we are not coplanar here. So no, they are not coplanar. So looking at the next example here, we want to take a look and say, and kind of bring in our vocabulary words here. Okay, our coplanar, planar, non-coplanar, linear, all that stuff. We're taking a look at X, B, and Y. Points X, B, and Y. They're uppercase, regular letters, so we know they're points. X, B, and Y. Notice they're all in this shaded region here. So we know that X, B, and Y are going to be coplanar. A, B, and C. Points A, B, and C. Well, we don't necessarily know if it's lying on this. I'll tell you right now, it's not lying on this plane together, but they are lying on the same line together. So together, line, collinear. Ray BA and ray BC. We're all on a line together. B is the starting point for both rays, and they go in opposite directions. These are going to be your opposite rays. And last, X, B, Y, okay, we're coplanar right now. Oh, then they throw in point C. Point C is not on the same plane as point X, B, and Y. So these are non-coplanar. Okay, non-coplanar. All right, last page. Let's take a look at what we've got. This next section isn't too important to worry too much about our definitions. A postulate is a statement that we go ahead and accept as true without proof. A theorem can be proved. Okay, we don't want to focus too much on that, but some things to remember here is that we've got through any 2 points, there is exactly one line. So through any 2 points, there's exactly one line. What this is going to be a 2-point postulate. Okay? All that means is that if you have 2 points, say A and point B, through any 2 points you have, there is exactly one line that can go through them. Sorry, it's a little messy. Okay, I'm going to clean it up a little bit for you. If you have 2 points, you can shoot one line straight through it. Doesn't matter where those 2 points are. Okay? Then when you have through any 3 non-collinear, not on the same line, points, there is exactly one plane contained. So this is your 3-point postulate. So if I have point A right here, let's say point B over here, and I have point C right here, I can take all 3 of those and I can draw a plane around them, exactly one plane. That's all that means. Okay? Then you have your plane line postulate. This means that if you have 2 points that lie on a plane, okay, so you got a plane, you got 2 points, then the line containing those points also lies on the plane. All right, so if we take a look at this, if we have a plane and we have 2 points, A and B, and they are on the same plane together, then the line that we talked about on the 2-point, that line that goes through them is also going to be on that plane. Okay? So let's take a look at this, the 2 examples that we have down here. The first one is asking, are points S, O, Q, and M coplanar? So here we have S, O, Q, and M. Well, Q, M, and O seem to be on plane T, but again, like earlier, we have this floating point. We have no idea where in space point S is. So no, they are not coplanar, because we could say our explanation is point S is not in plane, and was that T? Okay. Next, we want to know, do point S and point M determine a line? Can you put a line through point S and point M? Absolutely. The answer is yes. And how do we know that? Well, we just learned any 2 points make a line. Okay? Any 2 points can make a line. It's your 2-point postulate from right above on this page. All right, so hopefully we've got all of our notes and we've understood some new vocabulary terms.